When working with a 15 kilovolt-amps 480 volts transformer, it's important to understand the correct sizing of the disconnect and overcurrent protection. In the scenario presented, a 50 amps secondary receptacle is being fed by this transformer with a 30 amps primary breaker. However, you need to install a 60 amps disconnect ahead of the 50 amps load. To understand the reasoning, let's analyze the transformer's current relationships. The transformer has a 50 amps secondary current. The primary current can be calculated by dividing the secondary current by a turns ratio, which is derived from the kilovolt-amps rating and the voltage. While a 30 amps primary breaker might seem sufficient at first glance, it is undersized and does not meet code requirements for protecting the transformer and the downstream load. The primary current is not the only factor to consider when selecting the disconnect size. The National Electrical Code, or NEC, contains specific guidelines for transformer protection and disconnect sizing, particularly Article 450, which covers transformers. These guidelines are designed to prevent overheating, insulation breakdown, and potential fire hazards associated with transformer operation. Firstly, consider the primary overcurrent protection requirements. NEC Section 450.3 specifies the maximum overcurrent protection for transformers rated over 600 volts, nominal, and Section 450.3. B covers transformers rated 600 volts or less, nominal. In the case of this 480 volts transformer, Section 450.3. B applies. This section provides tables that dictate the maximum overcurrent protection based on the transformer's impedance. Secondly, refer to NEC Table 450.3. B, which generally allows for a primary overcurrent protection device rated at no more than 125% of the transformer's primary current, if the primary current is less than 9 amps. For transformers with a primary current of 9 amps or more, the overcurrent protection device must be rated at no more than 125% of the primary current. However, there are exceptions. If 125% of the primary current does not correspond to a standard ampere rating of overcurrent devices, the next highest standard overcurrent device rating is permitted. The 60 amps disconnect ensures compliance with NEC guidelines, providing adequate overcurrent protection for both the transformer and the 50 amp secondary load. Thirdly, consider the disconnect requirements. NEC Article 430 and 440 provide guidance on the proper selection and installation of disconnects. A disconnect is a safety switch that allows for de-energizing the transformer and its associated circuits for maintenance or troubleshooting purposes. The disconnect must be rated to handle the available fault current at its location and must be readily accessible. The 60 amps disconnect satisfies these requirements, providing a safe and reliable means of disconnecting the transformer from the power source. To summarize, the 60 amps disconnect serves multiple critical functions. Firstly, it provides overcurrent protection for the transformer, preventing damage from overload or short-circuit conditions. Secondly, it provides a safe and readily accessible means of disconnecting the transformer from the power source for maintenance or troubleshooting. And thirdly, it ensures compliance with NEC regulations, minimizing the risk of electrical hazards. Ignoring these requirements and relying solely on the 30 amps primary breaker could have serious consequences, including transformer failure, electrical fires, and code violations. Always consult the NEC and qualified electrical professionals to ensure proper installation and compliance with all applicable codes and standards.